Hey everybody. So we've got another couple of formulas here, the half-angle formulas. And so what I have right now is the reduction formula, one of them from last video. And these half-angle formulas are really not different than these reduction formulas. They just formulate them, they just write them in a little bit different way. So notice right now where we have sine squared theta is equal to 1 minus 2 cosine 2 theta over 2, right? So last time what we focused on was this was nice because we can turn something with a squared trig function into one without a squared trig function, and sometimes that's really important to us. But sometimes there's a different relationship that might be important. In this case, notice the relationship that the angle here in sine is half the angle of the angle and cosine, right? The way we've written it, it's more intuitive to say the angle and cosine is double the angle and sine, but those are equivalent statements to say the angle in the sine is half the one in the cosine. So if we rewrite it from that perspective, and we can make it really explicit, if I took something like, if I said alpha divided by 2 is equal to theta, right? Or that's equivalent to saying 2 theta is equal to alpha. I can rewrite this as sine squared of alpha over 2 is equal to 1 minus cosine of alpha over 2, right? And so this gives us a relationship between, this is where we see these half-angle formulas, that if you have half an angle, half of some number where maybe you know what the twice that angle is, it gives you a relationship to work with. Typically, the way this formula is written, and I'll write it over here, we take the square root of both sides, and we get the square root of 1 minus cosine of theta over 2. But we don't know if it's positive or negative, right? Because when we take the solutions, both of these would satisfy the original equation, right? And the plus or the minus has to be determined by other information. If we have some knowledge about where alpha is or where alpha over 2 is on our unit circle, we'll do an example in just a second. We can use those double angle formulas to make two other half angle formulas in exactly the same way. So this one looks like 1 plus cosine alpha over 2, and tangent of alpha over 2 is equal to plus or minus the square root 1 minus cosine alpha 1 plus cosine of alpha. And with a little bit of work, this can also be written as sine of alpha over 1 plus cosine alpha, or 1 minus cosine of alpha over sine of alpha. I'll leave that up to you to sort through. Okay, so there are our half-angle formulas, and they really are just the reduction formulas, taking the square root and just writing the relationship between an angle and its double and changing the perspective to an angle and half that angle, right? If I have twice as many apples as my friend has half as many apples as I do, right? So those are equivalent statements. Okay, let's do an example. Suppose, let's go to another page so we don't have to get crowded. So suppose we have that the sine of alpha is -4/5, and alpha is between, I've got 3 pi over 2 and 2 pi, right? So if you think about what this means on our unit circle, right, there's our unit circle. 3 pi over 2 is here, 2 pi is all the way around. So it's an angle somewhere in here in quadrant 4. Okay. With this information, let's find exact values for cosine of alpha over 2. Okay. So notice, I'll just put it right in here, that half angle formula we had, cosine of alpha over 2 is 1 plus cosine of alpha all over 2. And there's a plus or minus in front. We'll deal with that at the end. So let's start with, let's find, we want cosine of alpha over 2. If we can find a value for this, we can compute this whole thing. So let's go ahead and do that. There are a few ways we can do it. I'm going to use the Pythagorean identity. So I know that sine squared alpha plus cosine squared alpha is equal to 1. We know what sine is. So if we square that, so we've got 16/25 plus cosine squared alpha is equal to 1. Subtract 16/25 from both sides and just write your 1 as 25/25. So cosine squared alpha is going to be 9/25. And we take the root, which is going to be plus or minus 3/5. But notice we know that alpha is in quadrant 4. In quadrant 4, cosine is the x-coordinate, so it's positive. So I'm just going to write it a little closer. So we know that cosine of alpha has got to be 3/5. Okay, so now we can put it into our formula to get cosine, our half angle formula of alpha over 2. I still haven't figured out the plus or minus here. I'm going to save that for the end. I've got 1 plus 3/5 over 2, which is going to be, what do we get? 8/5 in the numerator, divided by 2. And this works out to be 4/5. And maybe we want to write this as plus or minus 2 over root 5. That seems like a reasonable way to write it. Okay, so there is our, there are our possible solutions for this. We're going to use this information about the location of alpha to get information about the location of alpha over 2. So the simplest way to do it is start with this, let's do it up here, inequality. Since we know that 3 pi over 2 is less than or equal to alpha, it's less than or equal to 2 pi. If we divide everything by 2, 2 is a positive number, so when we divide this, the inequalities don't have to change. We get this inequality. And so let's think about where this is. There is our, I guess I don't need the little arrow. All right, and then throwing a unit circle on here. And trying to center it a little bit. So let's see, 3 pi over 4. So that's almost pi. Pi is halfway around, so there's 3 pi over 4. And pi is right here, right? So it's between this angle and this angle, which means it's in this region, right? So instead of being in a quadrant, we end up with it in a octant, right? 1/8 of the circle. And in this region, notice cosine, the x-coordinate, would be negative. And so our answer must be that cosine of alpha over 2 is negative 2 over root 5. Okay, let's just do one last thing. Let's look at the region we started with. It was 3 pi over 2 to 2 pi. So we just halved this region, right? So this thing that went around 3/4 of the way around now goes 3/8 of the way around. So it's like this, we took half of this angle back. right? This first green angle was all the way around like this, and then we go back half that distance to there. The second green angle goes all the way around. When we cut it in half, we go back half a turn, and that's how we get this this little wedge of pi, right? So when we cut it all in half, it not only makes each like those terminal ends of the angles go backwards by half, but the size of the whole region gets compressed. Okay, that's it for this one. Like I said, these are a pretty straightforward continuation of the reduction formulas, just taking the square root and rewriting the relationship between the two angles from the other perspective. All right, thanks everybody. I will see you next time.